Stem and leaf diagrams are a quick and dirty way of seeing a pattern in the data, just simply kind of arranging numbers. Okay. You do have to set up an axis, but it's not nearly as involved as making a scatter plot or a bar chart or a pie chart. So stem and leaf diagrams are exploratory data analysis technique, which forms a graph by grouping the original data. The stem is the leading digits of each datum, and the leaf is the trailing digit of each datum. So the data set needs to be in ascending order. Okay, that's important. And the datum with the longest trailing digit sets the scale for the diagram. So let me give some examples. So if the datum in your data set was 227, then the last digit is the leaf, and the rest of the digits are the stem. If the data that you had in your data set, if one datum was 45.5, then this 5 is the last digit, that's your leaf, and everything else, including the decimal point, is the stem. If a datum in your data set was 3.02, the last digit is the leaf, and everything else is the stem. So when you take data and you separate it into stems and leaves, this is where the name for stem and leaf diagram comes from. So let's look at an example, to see how you create stem and leaf diagrams from data. So this example, we have the frontal shield length of common moorhens. We're going to make 1- and 2-sided stem and leaf diagrams. So bird watchers caught and measured attributes from 32 common moorhens. So that's a sample size of 32. One attribute of interest was the length of the frontal shield measured in millimeters. Create 2 one-sided and 1 2-sided stem and leaf diagrams. So what we've got here is actually 2 data sets. We've got a data set for the frontal shield measurement for male common moorhens, and there's 32 of those. And then we've got 32 measurements from 32 female common moorhens. And what you'll notice about all of this data, or all of the datums, is that all of these are accurate to 1 decimal place. And the other thing you'll note is that the data has been sorted in ascending order, meaning the first number is the smallest and the last number is the largest. So you've got a minimum value here and your maximum value there. And I've already identified which digit is the leaf. So the leaves are identified in bold. So remember the definition of stem and leaf. The leaf is the last digit of the datum. Okay. So that's where you've got 41.8, and the 8 is in bold because that 8 is the leaf, and the 41 point is the stem. Okay. So what you want to do is you want to take the datums and identify every leaf and identify every stem. Okay, so now once you've done that, you're ready to create stem and leaf plots. So the first thing we're going to do is we're going to create 2 one-sided stem and leaf. And that's what we've got here. So on the left-hand side, we have a one-sided stem and leaf plot for male common moorhens. And then to the right of that, we have a one-sided stem and leaf plot for female common moorhens. Okay, So if we look at the male stem and leaf plot, we have two columns. We have one column titled stem and another column titled leaves. And so what you do is you look at the first datum, and the stem is 41 point. So we're going to put 41 point here for the stem. And the leaf that goes with that is 8. All right. Now the next datum that we have is not a 41 number. Okay. So we need to go down to the next stem. So here we've got a stem of 42 point and a leaf of 3. So now we're going to put on the next row 42 point for the stem, and we're going to put 3 down for the leaf. Now let's look at the next datum. So the third datum. So the third datum is 42.8. So it has the same stem in the third datum as the stem in the second. So they both have a 42 point. So we're not going to make another row that says 42 point. We're going to use the same row, but now we have a different leaf. We have a leaf of 8. So we're going to put 8 here. All right. Let's look at the fourth datum. So the fourth datum is 43.2. And I just caught a mistake. So the stem is 43 point. And instead of a 9, that should be a 2. Right here. All right. And over here, the next datum is 43.9. That has the same stem, 43 point. We have a new leaf of 9. So we should put a 9 right there. Okay, now let's look at the next one. So the next datum is 44.0. 44 point is a new stem, so we're going to put that on a new line, a new row, and the leaf is 0. So we're going to put a 0. Then the next datum is 44.2. Okay, 44 point is the same stem, and the leaf is 2. So we're going to put a 2 here. The next datum is 44.4. That has the same stem and a different leaf. So we're going to put 4 here. All right, let's do the next one. So now we've got 3 datums that are 45.5. Okay, first of all, this is a different stem, 45 point. So we have to create a new row and put 45 point. So these next 3 numbers, even though these next 3 datums are the same, you know, with a leaf of 5, a leaf of 5, a leaf of 5, we have to put 1 5 for each datum. Okay. And then the next one is 45.7. So again, it has the same stem of 45 point, but a leaf of 7. So we're going to write 7 down. And then we've got 45.8. Again, that's the same stem of 45 point with a leaf of 8. So we're going to put an 8 here. All right, so now I think you can see where I got 46.0, 46.0, and 46.2, 46.2. And then lastly, 47.3, 47 is a new stem, and then 3 is the leaf. So what you've very quickly done by just making this stem and leaf graph is now you've given a shape to the data, okay? And you can see that there's more frontal shield measurements of around 44 and 45 millimeters. You know, that seems to be where the average is somewhere in that range. Now we can do the same thing with the female stem and leaf plot. So here we've got a stem of 38 and a leaf of 3. So we've got 38 points. Don't forget to put that decimal point with a leaf of 3. The next datum is 38.9. So we have a 38 point for the stem and a 0.9 for the leaf. And so I'm just going through this same process here of going through each datum, 39.2, 39.8, 40.2, 40.3, 40.7, 40.9, 40.9. So you can see where I've got 40.2, 40.3, 40.7, 40.9, 40.9. So I can construct a stem and leaf plot for female common moorhens. And when you look at the shape of that data, it looks something like that. And so it looks like, by comparing these two, that maybe the average size of the frontal shield of females is smaller than that of males. And so these are each, one-sided stem and leaf plots. Now we can create a two-sided one. Let me bring back this blue color here. So we can make a two-sided one simply by putting, like the female data on the left and then the male data on the right. I need to correct this mistake here where that should be a 2 and a 9. And so by putting the stem in the middle and then the leaves for the male on the right and the leaves for the female on the left, now you can see a more side-by-side comparison of the physical attribute difference between female common moorhens and male common moorhens. So this, in this case, we do have two different categories, male and female. So making two-sided makes sense. But in other cases, you may be given only, one set of data. And so you really don't need to make a comparison. You just have to make a one-sided stem and leaf plot.